All right, guys, we are going to start chapter 10.2, which is operations with radical expressions. Okay, here's a couple key concepts for this chapter. Please go ahead and get these recorded and replay me when you're ready for the explanation. Okay, so this is adding and subtracting like radical expressions. Okay, now we're just going to add or subtract the same way we did with monomials. Okay, so if I had, for example, 2x plus 7x, you just simply add the coefficients 2 plus 7 and we get 9x. Okay, so when we add like radicals, we're going to do essentially the same thing. So if I have square root of 11 and square root of 11, that's what I mean when I say like radicals, I just add their coefficients. So I have 2 plus 7 times the square root of 11, which is just 9 square root 11. Adding and subtracting, unlike radical expressions, first we must simplify, then add like radicands. Okay, and then multiplying radical expressions, we multiply two radical expressions with different radicands, is very similar to multiplying binomials. We're going to use distributive property and FOIL with those. All right, here's our first example. We have 4 square root 3 plus 6 square root 3 minus 5 square root 3. Notice that these are all like, so I can go ahead and just add up their coefficients. So we've got 4 plus 6 minus 5 times the square root of 3, and 4 plus 6 minus 5 is 5 square root 3. Okay, here's another example where I have a couple different radicands in there. I've got square root 5 and I've got square root 7. Now this is similar, the same thing when we had monomials, we add only like terms. So because of commutative property, I'm going to rewrite this so my like terms are next to each other. Okay, so all I did was I moved the square root of 5 with this square root of 5, and then these square root of 7s together with the other square root of 7. So now, right here, we're going to add our like terms. So 12 minus 8 square root 5 plus 3 plus 6 square root 7. 12 minus 8 is 4 square root 5 plus 3 plus 6 is 9 square root 7. Okay, now here's your turn, an example of both of those that I just did. Try these as best you can and replay me when you're ready for the answer. Okay, so here we write 3 minus 5 plus 1 square root 2, negative 1 square root 2, and we know that that's a negative 1, so we're just going to write negative 2, negative square root 2. Here we rewrite 15 square root 11 minus 11 square root of 11 minus 14 square root of 13 plus 6 square root of 13. 15 minus 11 square root of 11, negative 14 plus 6 square root 13. 4 square root 11 minus 8 square root 13. And that is it. Okay, so now we've got where we don't have any like radicals. So first of all, what we have to do is we have to simplify before we can add. So we're just going to make these little factor trees here, 2 and 10, 2 and 5. And because we already have a 2 out there, we need to make sure we write it. Find your pairs, cross one out, bring one out. And that's 4 square root 5. Same thing with this radican, 9 times 5, 3 times 3, 3 square root 3 times 3 times 5. 3 times 3 times square root 5, that's 9 square root 5. And again with 180, we have 10 times 18, 2 times 5. 18 is 2 times 9, 3 times 3. And we rewrite this as 2 times 2 times 3 times 3 times 5 we have 6 square root 5. Okay, so now, kind of ran out of room there. You would just keep going right underneath this, but I'm going to squeeze up here. 4 square root 5 plus 9 square root 5 plus 6 square root 5. And again, I just took these numbers here that we just simplified and put them up over here. Okay, so now that I have all like radicals, I can go ahead and add their coefficients. 4 plus 9 plus 6, square root of 5, and 4 plus 9 plus 6 is 19, square root 5. And that is your answer. All right, now your turn. I'd like you to give this one a shot. Make sure you simplify first before you go ahead and add your radicals. Okay, so here we get 3 times 4 times 2 times 2, 4 square root 2 times 2 times 3, 8 square root 3, 48, 6 and 8, 2 and 3, 2 and 4, 2 and 2, negative 6, 2 times 2 times 2 times 2 times 3, negative 6 times 2 times 2, square root of 3, and negative 6 times 2 times 2 is negative 24, square root 3. And then finally with 24, you did 4 and 6, 2 and 2, 2 and 3, and this is 5 square root of 24. Nope, not 24. Square root 2 times 2 times 2 times 3. 5 times 2 times 6, and that's 10 square root 6. Okay, so we've got 8 square root 3, negative 24 square root 3, and 10 square root 6. So I'm going to come over here so I have a little bit more room to work. All right, so now with this, I'm going to add my like radicands here and here. So I have 8 minus 24 square root 3 plus 10 square root 6. And 8 minus 24 is negative 16 square root 3 plus 10 square root 6. And I can't do anything with this square root 3 and square root 6, so I just leave it like this. Okay, now this is probably the most challenging part, or there's the most steps involved. I wouldn't say it's challenging, but this is where we have a radical expression times another radical expression. And this looks similar to when we had multiplying binomials, we had to use the FOIL method. So we are going to do the same thing. First, which is 4 square root 5 times 3 square root 6 times the outside, 4 square root 5 times negative square root 10 times the inside, which is negative 2 square root 3 times 3 square root 6 plus the last, which is negative 2 square root 3 times negative square root 10. Okay, so once we got our FOIL, we just go ahead and simplify and multiply and all sorts of stuff from this long line. All right, so here we get 12 square root 30 minus 4 square root 50 minus 6 square root 18 plus 2 square root 30. And all I did here was I multiplied your coefficients, and then I multiplied the radicands. Okay, and then from here, we've got to do our little factor trees. 3 and 10, 2 and 5. We've got 12 square root 2 times 3 times 5. There's no pairs here, so it's 12 square root 30. And then here we have 50, so we do this as 5 and 10, 2 and 5. And we have negative 4 square root 2 times 5 times 5. We've got one pair. Negative 4 times 5 times square root of 2, which is negative 20 square root 2. 18 comes in 3, 6, This is 2 and 3. We have negative 6 square root 2 times 3 times 3. Circle one out, bring one out. Negative 6 times 3, square root of 2. It's negative 18 square root of 2. And then finally with 30, we already actually just did 30, and we found out that it does not, can't be simplified anymore, so we're just going to bring that down to 2 square root 30. Okay, so we have 12 square root 30 minus 20 square root 2 minus 18 square root 2 plus 2 square root 30. Okay, and then we're going to combine our like terms together. Square root of 30 and square root of 30, we're going to add those coefficients of 14 square root 30. And we have a negative 20 square root of 2 and a negative 18 square root of 2, and that's negative 38 square root 2. And this, my friends, is your final answer. Okay, now this one is your turn, and I want everyone to try it. Don't just let me work it out for you. I want you to actually try it. There are a lot of steps, but it's definitely doable. So go ahead and give it a shot and replay me when you're ready for the answer. Okay, so we do the first, outside, inside, last. And we get 5 square root 5, 6 square root 10, plus 5 square root 5, negative 2 square root 6, minus 4 square root 3, times 6 square root 10, minus 4 square root 3, times negative 2 square root 6. And this becomes 30 square root of 50, minus 10 square root of 30, minus 24 square root of 30, plus 8 square root of 18. And when you simplify this, this becomes 150 square root of 2, minus 10 square root 30, minus 24 square root 30, plus 24 square root 2. And we can rewrite this with 150 square root 2 plus 24 square root 2 minus 10 square root 30 minus 24 square root 30. And this becomes 174 square root 2 minus 34 square root 30. Okay, hopefully you got that one right. There was a lot of steps involved. I didn't show my work with simplifying, but you should. Just for time's sake, I wanted to make sure I got it in there. Okay, now here are your practice problems. Notice with this one right here, we did not do an example like this one. However, we have seen that before. All that is just simply distributive property. So you're going to distribute that square root of 2 to both the square root of 8 and 4 square root of 3. And I think you guys can handle that. Go ahead and give these a try, and we'll go over them first thing next time I see you.